Okay, so good morning to all and welcome to lecture number 4. And today we'll finish chapter number 1, I hope. In the last lecture, we talked about the difference between the open loop system and a closed loop system. I'll take the recap of that one very quickly, and then we'll go ahead with our today's presentation. So in open loop system, as I said that there is no feedback. Whereas in case of closed loop system, there is a feedback. So this feedback element is present. Also, one more thing is that comparator is present in the closed loop system, which is not present in the open loop system. Second difference between the open loop and closed loop system is that controlling action is totally independent of the output because we are not measuring the output. So this controller action or controlling action is totally independent of the output. Whereas in case of closed loop control system, controlling action depends upon the output. Okay, whatever is the output, according to that, feedback will be given, and the output of controller will change according to the feedback. So this controlling action depends upon the output in case of closed loop control system. Third difference what we have studied is that these open loop systems are very simple in construction and design. Okay, very less hardware is required. Whereas closed loop control systems are complicated and time consuming from design point of view as compared to the open loop system, right? And fourth difference is that these open loop systems are economical and because less hardware is required, whereas these closed loop control systems are costlier compared to open loop system, right? The fifth difference what we have seen is that these open loop systems are inaccurate and unreliable because accuracy of such systems are totally dependent on the accurate pre-calibration. So pre-calibration is necessary in case of open loop control system, whereas calibration, time-to-time calibration is not required in case of closed loop control system, and we are measuring the output or we are taking the feedback, and that's why accuracy is always high as of closed loop control system as compared to the open loop system. The sixth difference is that output changes with internal and external disturbances. Means if there is an internal or external disturbances, output of this open loop control system may change. But this disturbance does not make any difference because even if there is a change in output, automatically this output is fed back to the feedback element and controller will take the action. So if there is a change in output, it will be corrected automatically in case of closed loop control system. And that is not happening in case of open loop control system. The seventh difference what we have seen is that to maintain the quality and accuracy, time-to-time calibration of controller is necessary, whereas in closed loop control system it is not necessary, right? The eighth difference is that these open loop systems are generally troubled with the problem of instability. Okay, whereas means actually this is not a difference, but similarity we can say that because there is also a problem of instability in case of closed loop control system because there is tendency to overcorrect the error, and this may cause the instability. So the reasons may be different, but instability problem may be there in both system, right? Then we have seen the last difference of the example of open loop control system. So automatic washing machine is one of the example of open loop control system. Traffic control signals are also one of the example of open loop control system, whereas human being is a natural control system, which is closed loop control system because we get the feedback from 5 sensory organs. Also temperature controller or your air condition is also a closed loop control system. So that is what we have learned in the last lecture. Now we'll study the further differences between the other systems and so on. Now servo system generally used in a control system. So servo system is basically or it is also called as the servo mechanism, is a feedback control system in which the output is somehow some mechanical position or velocity or acceleration. So see that this antenna, like for example, antenna may be rotated, or even like for example, if you're this one, you would like to track the system or tracking the system and so on. So according to that, the object you have to change the antenna and so on. Or solar system also, you can make the solar system which will track the sun, and then you'll get the maximum sunlight, and because of that you can generate the maximum electricity from the solar system, and so on. So changing the solar panel according to the direction of the sun is also a mechanical system, because its output is changing position of this solar system, or change of antenna position is also the mechanism. Means basically where your input is electrical system and then your output is mechanical system, which is changing the position or velocity or acceleration and so on. So such systems are called as the servo mechanism, where you have a feedback system involved in that. Now we'll see the next systems, like as what is meant by linear control system and what is meant by non-linear control system. So in the second year you might have seen or you have studied in network theory this one superposition theorem. So you know the superposition principle, which obeys the linearity and so on. Means like, for example, if you give the input, like for example this is the process or systems, and if you give the input ut or ut1, you get the output yt1, right? So when input is ut1, your output is yt2 yt1, right? But if you change the input, like as a ut2, you have given the input second input ut2, their output will be yt2. Now see that when input is ut1, you got the output yt1. Now you have changed the input for the system, and now your input is ut2. Your output at that time you are getting as a yt2. Now in the third case, when you combine the input first and second input, like as a ut1 plus ut2 you have applied here, and then your output is such that it is giving the output as a yt1 plus yt2. Okay, so if your output in this case, if your input is ut1 plus ut2, then your output is yt1 plus yt2, then such systems are called as linear systems. So your basically output is a linear, okay, whether it is increasing in okay nature or whether it is decreasing in nature. See that this is the linear system which is decreasing, like as a y of t is equal to minus 2 of u of t plus 1. So this output decreases with increasing u of t, right? Whereas if your y of t is 3u of t plus 5u, so in that case, as u of t goes on increasing, your output also goes on increasing. Now see that if you basically combine this out in both the input, your output will be equal to this output plus this output. Now see that there is a relation between a linear relation between y of t and u of t, also y of t and u of t. Only thing is that here it is decreasing in nature and here it is increasing in nature. So such systems are called as a linear system, or if it is control system, then it is called as a linear control systems, right? So the systems which obeys the principle of superposition, those systems are called as linear control system. And non-linear control system, those systems which does not obey the superposition principle are called as non-linear control system. Means basically there is no guarantee. See that non-linear control system. So in linear control system, basically what is in non-linear control system, your output is non-linear, right? So there is no linearity, this one relation between input and output, and basically it happens when it does not obey the principle of superposition, right? Means if your input is x1t, your output is y1t, and then if you change the input from x1 to x2, your output is y2t. But it does not give when you combine the input x1 plus x2. At that time, in case of linear control system, your output will be y1t plus y2t. But in case of nonlinear control system, your output will not be y1 of t plus y2 of t. It's not there. So this superposition principle does not hold in case of nonlinear control system. So your output will be nonlinear and so on. So, but sometimes basically that system may be linear for some region. Okay, and but beyond that one, it will not be a linear and so on. So nonlinear control system is that when the input and output has nonlinear relationship, the system is said to be a nonlinear. See that this input and output is a having nonlinear relation, and it does not obey the superposition principle. So if you basically see the difference between linear control system and nonlinear control system. So the difference is that first one, a control system is said to be linear if superposition principle applies to it. Okay, for linear control system, relation between input and output is linear and it holds the principle of superposition. Okay, we have seen what is by superposition principle. Whereas in case of nonlinear control system, your relation between input and output is nonlinear and it does not obey the principle of superposition. So this is the first difference between the linear control system and nonlinear control system, right? Then the second difference between linear control system and nonlinear control system is that the response to several input can be calculated by considering one at a time and adding the individual results. See, that means when you are applying x1, you are getting the output y1 in case of linear control system. When you change the input from x1 to x2, you get the output y2. If you change to x3, you'll get y3. Now, overall output of this system will be equal to, okay, if you apply x1 plus x2 plus x3, your output will be y1 plus y2 plus y3. So this can be calculated in case of linear control system, whereas this is not possible because it does not obey the superposition principle in case of nonlinear control system, right? Whereas in a case of linear control system, the third difference is that solution is simple in case of linear control system, whereas in a case of nonlinear control system, solution is time consuming and complicated, right? So solution is time consuming and complicated. So this is the third difference between the linear and nonlinear control system. The fourth one is that most of the real world systems are not linear. Okay, real world systems are non-linear, but see that mostly linear control systems, real world systems are non-linear, and solution to this one is basically time consuming and complicated, and also okay, so you have to design this non-linear control system, okay, in terms of linear control system, because some portion of that, okay, piecewise linear combination, considering the piecewise linear combination and so on. So this is the difference between linear control system and a non-linear control system. So we have seen the four difference between linear and non-linear control system. First one is that linear control system holds the superposition principle, whereas nonlinear does not hold. Second thing is that you can, okay, predict the output if you combine the input. So to the response to several input can be calculated. This is possible in case of linear control system, whereas it is not possible in case of nonlinear control system. Third difference is that solution in linear control system is simple, whereas in nonlinear control system, solution is time consuming and complicated. And the fourth most important difference is that most of the real world systems are not linear, whereas most of the real world systems are non-linear control systems, right? So this is the difference between linear control systems and non-linear control system. Now we'll see the second types of control system, that is what is by time invariant control system and what is by time variant control system. So you know that the system whose output does not change with respect to time. Like, for example, I have designed a control system, or simple in our electronics language, suppose, for example, we have designed a voltage regulator for output voltage equal to 10 volt and load current is equal to 2 ampere, right? Now, it is expected that this voltage regulator will give the output, okay, which is equal to 10 volt, and load current will be equal to 2 ampere. Whether, okay, it's not like that, okay, this voltage regulator will give me output 10 volt and 2 ampere current at 10 a.m. or during daytime, and during night time it will change the output, or like that. It's not like that. At any instant of time, your output remains same, so it does not vary with the time. So that control system is called as time invariant control system. Means the system whose output does not change with respect to time, that system is called as the time invariant control system. Whereas the system whose output depends upon the time, okay, that kind of control system may called as a time variant control system. So designing time invariant control system is easy as compared to time invariant control system. Okay, time variant control system. We will see the example of this. What are the example of time variant control system or time okay, invariant and time variant? See that I have given the example of this time invariant control system like as a voltage regulator whose output will be always equal to 10 volt if you have designed for 10 volt. So irrespective of time, its output will be equal to 10 volt. But like for example, in this one missile launching or this one in space aircraft and so on. So designing the space aircraft, so while launching that space aircraft, you know that when it goes from this one, okay, when this launching starts, its mass will change with respect to time. When it go away from the Earth, okay, station, its mass will change as okay time passes and so on. So such kind of system is called as the time variant control system. So designing time variant control system is difficult as compared to the system time invariant control system. So when the characteristic of system do not depends upon the time itself, then system is said to be time invariant control system. That is y of t is equal to minus 2e of t plus 1. And time varying control system is a system in which one or more parameters vary with time. So see that here this parameter is varying with time, so it depends upon the time. As t changes, your output also changes. But here there is no factor of t, like okay, so your this input is there, so your output depends upon the input only. So u of t is the input. So here, whereas in this case your output depends upon the input as well as the time. Okay, so as time changes, your output will also change. So this system is called as time variant control system, whereas this system is called time invariant, because not a single parameter is dependent on the time here basically, right? But this factor depends upon the time. So this is time varying control system and this is time invariant control system. So if you look at the difference between the time invariant control system and time variant control system, first one is that system parameter does not vary with time in case of time varying control system, in time invariant control system, whereas time variant control system parameter varies with time. So parameters will vary with time. Then second difference is that the response doesn't depend on the time. So its output doesn't depend on the time, whereas here the response depends on the time at which an input is applied. So if you have applied the input at 10 a.m., or your output may be different. If you apply the input at 5 a.m., your output may be different. This is possible in case of time variant control system, whereas in case of time invariant, whether you apply at 10 a.m. input or at 5 p.m., your output will remain constant or same. So example of this time invariant control system is that air conditioner or temperature controller is, or even voltage regulator. You take any, most of the systems are time invariant control system, whereas the example of this one time variant control system is that space control system whose mass decreases with time. So as time changes, its mass will decrease, and as it go away from the Earth station, its mass will decrease and so on. So that is called as the time variant control system. So I hope that you have understood the difference between time invariant control system and time variant control system. Then lumped parameter versus distributed parameter. Okay, lumped parameter, you might have studied this one in your even network system also, where basically your output, okay, parameters which are individual, okay, whereas distributed parameters are not individual. So a control system that can be described by ordinary differential equation are lumped parameter control systems. Like as for example, this is nothing but the mass system, force equation of the mass system. This is nothing but the force equation of the dashpot, and this is nothing but the force equation of the spring element and so on. So mass, dashpot and spring, these are okay individual elements or we can call that as a lump parameter control systems. Okay, the systems which are made up of simple mass or dashboard or spring, or simple in case of electronic system control system, like for example, if you have designed a control system with the help of lumped like this one register or inductor or capacitor. Okay, individual resistor, capacitor, inductor are there, and then if you have designed that control system by using such components, then that system is said to be a lumped control system. Okay, whereas the distributed parameter control systems are described by a partial differential equation. See that this is defined. Okay, your lumped parameter control system is defined by ordinary differential equation, whereas distributed control systems are described by partial differential equation. So this is partial derivative of x with respect to y and with respect to z, and then double derivative and so on. So such systems are called. So by looking at the mathematical model of a control system, you can identify whether this is a lumped control system or whether it is a distributed control system. You know the example of distributed system like as a this one. You know that tower line, okay, or power lines are there. So power line where inductor, capacitor and resistor is distributed all over the line. So that kind of systems are called as the distributed systems and so on, right? Now the fourth system where we'll see the difference between the control system is that the continuous system, continuous control system and discrete control system. So in continuous data, you're in the continuous data control system, all the system variables are function continuous function of time. See that this x of t is always a function of time. So x of t is always or continuous this one function of a continuous time t. Whereas in discrete time control system, system involves one or more variable that are known only for discrete time. Like for example, this x of x1, x2. So this x1 is available at n1, x2 okay, x2 is available at n2, x3 is available at n3. So between n1 okay, n1 and n2 there is no xn available, but here x of t is always available. Okay, so this kind of system is called as the continuous control system, and if the parameters are in discrete nature, then that is called as the discrete control system and so on, right? So I hope that you have understood the difference between the continuous control system and discrete control system, right? Then so you can see the difference between the continuous time and discrete time control system. So you know that all the system variables are the functions of continuous time variable t in the case of continuous control system. So all the system variables are the function of continuous time variable t, whereas in discrete control system, they are not continuously dependent on the time, right? So this is the first difference between the continuous time control system and discrete time control system. Second difference is that all the system variables are known at every instant of time. See that, look at all the system, this system variable is known at every instant of time. But in case of discrete system, this is only known for what? It is known for only n1, n2, but between n1 and n2 this is not known. So discrete control systems are one or more discrete systems are variables are known only at a certain discrete interval of time. So this one example of this continuous control system is analog control system, and example of discrete time control system is digital control system. Okay, so digital computer control system is example of discrete time control system and so on. Now the last type of control system is deterministic control system and stochastic control system. Deterministic control system means basically okay, a control system is deterministic if the response to the input is predictable and repeatable. Means if you know the x1, you can predict the output of that system, right? So if you okay, means basically you have the mathematical modeling of that system, right? So simple system, like for example, if you take the Ohm's law, what is Ohm's law? V is equal to I into R, right? So if you know basically voltage and resistance, you can predict the value of current. Okay, so whatever may be the voltage and resistance, you can predict the value of current. So that is called as a deterministic system. Means basically you can predict the value of the output, or if you know the current and resistance, you can predict the value of voltage, or if you know the current and voltage, you can find the value of resistance and so on. So the systems where you can predict the output and it is repeatable. It's not like that, for example, your output is okay, at 10 a.m. your output is something and at 5 p.m. output is different. It's not like that. Whether it is at 10 a.m. or 5 a.m. your output will be same. So a control system is deterministic if the response to that to the input is predictable and repeatable. So you can predict what will be the output of that control system, or it will be repeatable. So such kind of control systems are called as deterministic. Whereas in stochastic control system, this is not true. So control system, we cannot predict the output in a stochastic control system, and okay, it is not repeatable also. Okay, so designing the stochastic control system is difficult as compared to the deterministic system. So if not, the control systems is stochastic control system. Like, okay, we cannot, output is not predictable here, as well as output is not repeatable. So such kind of systems are called as the stochastic control system, right? Then the adaptive control system is basically the dynamic characteristic of most of the control systems are not constant for several reasons, and you have to change the things or change the parameter, depends upon the situation and so on. So that kind of control system where parameter may change depends upon the situation, that kind of systems are called as the adaptive control system. So the dynamic characteristic of most of the control systems are not constant for several reasons, and the effect of small changes on the system parameter is attenuated in a feedback control system. Okay, and adaptive control system is required when the changes in the system parameters are significant and you have to change the output accordingly. So this kind of systems are called as adaptive control system. Automatically your system parameter changes, and then according to that you have to adjust the output. So that kind of systems are called as the adaptive control system. Now already we have seen linear, what is by linear control system, what is by non-linear control system, what is by time variant control system, what is my time invariant control system, then continuous system, discrete system, stochastic system, and then this one deterministic system. Also we have seen this one lump system and distributed system. So all those are the, or even open loop control system and closed loop control system. So these are the different types of control systems. So see that the types of control system, if you see overall this one, it in what way we have studied. Initially we studied control system of the difference. First one is natural control system, that is our human being is the example of natural control system. All other systems which are designed by the human or engineers are man-made control system. These man-made control systems are further classified into manual control system or automatic control system. So here human intervention is needed in case of manual control system, whereas here human intervention is not needed. So like for example, we have seen that fan is the example of manual control system. To change the speed of that, we have to go and we have to change the regulator knob. Whereas if you take the example of AC, okay, once you set the temperature of AC to 23 degrees Celsius, it will automatically maintain the room temperature 23 degrees Celsius. So that is the example of automatic control system, and so on. Then these automatic control systems are further classified into open loop control system and closed loop control system. So in open loop also, these are further classified as a non-linear control system and linear control system. So you know that open loop control system means there is no feedback, whereas closed loop control system there is a feedback. So these are simple in design, these are difficult in design, this is okay, economical, this is costlier, and so on. So we have seen 9 differences between open loop and closed loop control system. After that, this open loop are further design, okay, may be classified as a non-linear control system and linear control system. So linear control systems are said to be linear if they okay, they are linear if they this one obeys the superposition principle, whereas non-linear control system does not obey the superposition principle, and so on. Okay, we have seen the difference between linear and non-linear. Whereas closed loop control systems are for also designed as a non-linear control system and linear control system. And then in this linear control system, this is okay, system can be a time variant control system or a time invariant control system. So you know that time invariant control system means the system in which your output does not change with respect to time, whereas time variant control system, your output changes with respect to time. So we have seen the example here like voltage regulator or AC or something like that, whereas the spacecraft system is time variant control system and so on. Whereas non-linear control systems are further designed as a time variant and time invariant control systems and so on. So like that way, this is the overall difference between all those types of control system. And okay, generally we will study in our entire course control systems which are man-made, which are automatic, which are most of the time which are closed loop, and most of the time linear, and which are time invariant control system. So this is focused in our syllabus because we are studying the basic control system and so on. The advanced control system, okay, people can study non-linear design and then non-linear control systems and then time variant control system and so on, right? So this is the entire thing that is linear time invariant control system we will be studying in our entire course. So system is said to be linear if it is okay, obeys the superposition principle, and if its output does not change with time, then that is called as the linear time invariant control system. So system is linear and it does output does not changes with time, so that is called as linear time invariant control system. So in our, as I told you that in our entire course will be more focusing on this part of the control system. Okay, so thank you very much. And this finishes our chapter number 1, which was the introduction of control system. And in our next lecture we will be starting the chapter 2. That chapter 2 is also very small chapter, and hardly it may require 1 or 2 lectures, right? So see you in tomorrow's lecture at regular time. Okay.